Hello everybody, Mr. McVeigh here. This time we're going to talk about transformations of parabolas, and specifically only translations at this time. So we know the vertex form of a parabola is a times quantity x minus h squared plus k, where the vertex is at h and k. If a is positive, it opens up. If a is negative, it opens down, and the axis of symmetry of the parabola is at x equals h. Remember, for the vertex, we always have to change the sign of the given h. K stays the same, so the left kind of lies, the right tells the truth, but you got to change the sign. Okay, so we look at this particular example right here. We see there's no k, so k is actually 0. So we know our vertex is at h. In this case, it's -2, comma, and 0. And I've already filled out some points here, or the x values of the coordinate pair, and we'll fill in the rest to actually plot our parabola. But we know our vertex is at -2 and 0. And so let's go ahead and plot that. -1, -2, 0. There's our vertex. We know it opens up because this is positive, so we know it opens up. Let's substitute in some more points to get our y values, our vertical values, for our particular graph here. So -4 plus 2 is -2 squared is 4. -3 plus 2 is -1 squared is 1. And since this is the axis of symmetry, I can actually substitute those points in and calculate it, or I know they'll just be reflected across my vertex, or my axis of symmetry right here, my axis of symmetry. And so the last one will be 4. Okay, let's plot these points really quick. So at -3, I have 1. And at -4, I have 4. 1, 2, 3, 4. Here's my axis of symmetry. I'm going to draw this in red. My axis of symmetry. Okay, the easy way to do this is you can plot the point, or you know that it's an equal distance from the axis of symmetry on each side. So that one plots there. And this one is 2, so 1, 2 plots there. I know it opens up. There's my parabola. And now what can I say about this parabola? What did it do? Which way did it move? In other words, which way did it translate? Well, I can see that it moved only left 2 units. And so I could say it moved left 2 units, and that's all. It didn't go up or down. So look at this next example. This example has x squared plus 5. You notice there's no parentheses. A lot of people will get confused on this and they say, well, what do I do? Well, remember, this is the same thing as writing y equals x plus 0 squared plus 5. You notice there's no h value in here. There is, it's h, it's 0, but it's just understood to be there. So we can say, okay, so my vertex is at 0, comma 5. Okay, so 0, it's at 5. My axis of symmetry is at 0, x equals 0. Let's draw it in. Axis of symmetry right here. It didn't move, did it? It's right on the y-axis still. This is the x-axis. Let's plug in a point. -1 squared is 1, plus 5 is 6. -2 squared is 4, plus 5 is 9. Here's my axis of symmetry. So instead of plugging these in, I can just reflect them. And now I can plot them. So at 0, I get 5. 1, 2, 3, 4, 5. I know it opens. This is positive, so it opens up. It opens up. Okay. At -1, I get 6 is here. Across, select one across the x-axis. I'm sorry, the axis of symmetry. My next one is at -2. It's 9. It's way up here somewhere. And this one reflects across. My parabola opens up. And it didn't move left or right, but it did move up 5 units. Okay. Let's look at our next example. Okay. This one has both a left and right translation and an up and down translation. So I know my vertex is at -1 and -6. So -1, I'm at -6. I can choose a few points. How about 0? 0 plus, I like 0 because it's easy to multiply by and add. So 0 plus 1 is 1. 1 squared is 1. 1 minus 6 is negative 5. 1's a good number too. 1 plus 1 is 2. 2 squared is 4. 4 minus 6 is negative 2. I know I can reflect these across the axis. 5, negative 2. Start plotting my points. So at 0, I'm at negative 1, 2, 3, 4, 5. And at negative 1, I'm at negative 6. My axis of symmetry is right here. I'm going to draw it in. I know this reflects across here. My other point is 1 and negative 2, so 1 and negative 1, negative 2. It reflects across the axis of symmetry 2 times. That's the same as this point. We know it opens up because it's positive. And what can we say about this parabola? Well, we can say it shifted left 1 time, so it went left 1. And it went down, how many? 1, 2, 3, 4, 5, 6. It went down, went left 1 and down 6. We'll talk about that again in a minute. Our last example, on our last example, this is negative, so we know it opens down. We know it opens down. So it's already flipped. There's a flip in this one. Okay, so what's my axis of symmetry? Well, first off, my vertex is going to be at 4, change the sign, k stays the same, so 1, so 4 and 1. I plug in some points. At 2, I end up getting negative 3. At 3, I get 0, and where my fractions are, plug them in, is 0 and negative 3. Okay, so if I plot this one, I know my vertex is at 4 and 1, so it's 1, 2, 3, 4, and up 1. I know it opens down, so my next point is at 3 and 0. My axis of symmetry is right there. It's at I have a point here. I have 2, 1, 2, and it's down 1, 2, 3. My axis of symmetry. To make this easy, it plots right over 2, over 2. It opens down. And there's my parabola. And so I could say now we know that it flipped. So it transformed in a flip, but it also moved right 4 units and up 1 unit. Now let's look at each one of these individually for just a second. We know this moved left 2. Will you notice this where this h is from our original parent function? This is a parent function already drawn in. Parent is y equals x squared. We know it moved left 2. Well, we can see that, you see the 2 here in the h? Well, it moved left 2. So we can say, well, yes, it moved left 2 without actually ever having to plot this. We know it moved left 2. On this one, in this example, it didn't move left to right because the h was 0, but it moved up 5. And sure enough, we counted it up 1, 2, 3, 4, 5. So it moved up 5. We can see that. And that's what this demonstration is about. In our third example, it moved left 1. You can see the left 1. Here it moved left 1. And it moved down 6. And sure enough, that's what we got when we plotted it. And finally, we moved right 4, and we can see we moved up 1, and then when we plotted it, it's exactly what we got. So these are good demonstration of how we can translate in one flip for parabolas out of vertex form. See you next time, Mr. McVeigh.